Okay, so that brings us to 11.6, where we need to work with images. So we are given an image file that corresponds to this image, and then we need to implement a function extract subimage that allows us to basically select a part of the image and plot it using some built-in function in Matplotlib. Before we get to that, we should probably talk a little bit about how images are stored in the particular file format that's considered here. So what I'm going to do is that I'm going to go to the file that we need to work on, which is extract subimage. So let me do that. Yeah. And then what I'm going to do is that I'm going to, I prefer to have these if statements in the bottom. They're a little bit optional, but it basically means that whatever I put here will not be run when I run the tests, and I find that convenient. But I'm going to insert this code here for plotting the image in the bottom. If you think this is like really annoying, you can just ignore it and write this. Then it's just going to plot quite a lot. So I prefer to keep it like this. Anyway, what I was saying is this is how we can apparently plot an image, and I think it's worth looking at what this code does in a bit more detail and talk a little bit about how images are represented before we move on with the exercise. So I'm going to insert a breakpoint here, or actually I'm going to insert a breakpoint here, because I want the code to run until this line and not execute this line, because this has to do with the plotting, and I want to talk a little bit about how the images themselves work. So, okay, so what's happening here? First of all, there's a little bit of file magic going on. So we can see we have a file called comic.mpy. Let's just find it. Files, we have this file here. Well, God knows what this file format is. There's just a function in Python called load, and apparently that does some loading. It returns something. What does it return? Well, it returns something we store in this image variable, and we can see that it's a really big two-dimensional array, and it looks like it has integer entries. So if you look at the shape, it's 423 times 500 dimensional, and if you look at the maximum and the minimum element, we can see that all the elements are between 0 and 255. Now this is actually what we plot in the next line as an image. So this big array corresponds to this image here. How does that work? Well, it works because in this particular file format, which is fairly common for images without colors, all the entries in this array indicate the intensity of a particular pixel in such a way that 0 corresponds to the pixel being completely black, and 255 exactly corresponds to the pixel being perfectly white. And everything between is like a grayscale, like degrees of grayness. So the way the pixels in this array physically map to this image is that the pixel at entry 0.0, that would be this entry here, correspond to the pixel right here in the upper corner. And the pixel here would correspond to the entry, like it would correspond to this entry in the array. So we can access this by doing -1. So we use that, we can use negative indexing to get to the bottom, comma 0, and that will give us this pixel, like this pixel right here. And it's actually already indicated by the axes here. These are the Matplotlib axes. And this one we could access by -1, -1. So we can see that this image has a white border around it, so that's why when we select the entries, it's not super interesting. So the next line here, imshow, it's just basically telling Matplotlib to plot the image. You don't really need to know what it does, except that it sets the color map to gray. And the reason why I prefer to do this stuff is because Otherwise, whenever I imported this script, instead of running it, Matplotlib would jump up with a plot, and that would be a little bit annoying with the testing. So that's why I prefer to have this stuff here. Okay, so armed with that knowledge, we can work on the function that we need to write, extract subimage. So we have 2 lines with an example. So I'm going to remove you, put in the example here, like this. So your function should take an image, the upper left corner of the zoom image, and a size as input. Okay, so the way it works is that we give it this array, and then we give it the upper left corner of the zoom image. So like where we want to start cutting, for instance 0, 0 would be here. And then the next 2 coordinates is how like high and wide the subimage should be. So down and right from here. So we, in this case 0, 0 and this, if you consider the size of the original image, it would be exactly like this quadrant that we pick out. And that's why when we plot it, it will plot this smaller image. So notice the axis has changed appropriately to these 2 here. So that's the one we need to implement. So I'll do it the usual way by inserting a random thing here so I can put in a breakpoint. Then I'm going to stop the debugger because I changed the file a little bit, and then I'm going to restart the debugger and now use that. It'll call my extract subimage function, start calling it, and hit the breakpoint, because now I can experiment with the arrays. The debugger becomes progressively more important and useful the further we get in these exercises. And I would say an exercise like this, it's really, really helpful actually. So here's the image, here's the start point, and the size. Cool. So, yeah, okay. So we have image, and then like it has this shape. Like let's say I want to start at pixel number 100 and pixel number 2 number 0. I could access it like this, but then I can get the I can use slicing to get like the sub part of this array that starts at 100 and like 100 down and 0 out, so that would be here somewhere, and then just using the slice to get like everything else, that's this slice, like down, and everything to the right, that would be this slice. So this would give a sub part of the image out, and I can check the shape is correspondingly smaller. In other words, if I did this, I would get like a smaller quadrant of the image out. Let's do this in an experiment. So let's say we store this as a variable image, and I already imported Matplotlib, so I can plot it here. So let's plot this imp show, and we get to give it this color map thing. Otherwise, it'll look a little bit funny. But even if you ignore it, it'll still be something. I'm actually not completely sure what. So we can see that it seems to select a sub part of the image. Maybe we can experiment a little bit with it. So let's start at 50, and let's start at 20. So if we keep track, 50 would be around here and 20 would be around here. So it's like this part of the image. So let's see what that will do. I just copy paste it down here. Let's copy paste. Oops. Didn't copy paste it wrong. Yeah, okay. So it popped up and I didn't see correctly. So we can see here that it starts at like 50, so quite a far down, and then it cuts off a little bit of the left part, but then it selects the rest of the image. So of course, if I stop the slice somewhere, so let me stop this at 200 and let's stop this at 90. It's going to select like a rectangular rectangular region of the matrix. So it will start here, and then it will like select a internal part of the image. So let's just confirm that by running this code. So I select it and then Shift-Alt-E. I could also copy paste it down in the terminal. So now we see we select a small rectangular region. Okay, so armed with that knowledge, we can it's sort of just a matter of changing this and this and this and this to be commensurable with the information that I'm given up here. So that's the next thing that I'll do. So let's start by getting the coordinates of the start point, and we'll say that these are called x and y, and we'll do a little bit of tuple unpacking. So the start point is this. When I run this line, it unpacks this tuple, and x is 0 and y is 0. So obviously I need to start, I need to start at, start point, is that x or y, or is it image coordinates? I guess it would be like y and x, right? That would be correct. Does it say that? Your function to take the image, the upper left corner. So it's a good question, upper left corner. So what I'm wondering about here is if upper left corner is like the x, y position of the upper left corner, or if it's like the down right position. I think it's down right. Of course, with 0 and 0, it doesn't matter which way I turn them, but I think it would be, let's call it down right, like this. Need to start so far down and so far to the right. Okay, so that will create the right starting point of the slice. Now size is like the height and width of the image. So that will be equal to the size. So if I run this, I get height and width set automatically from the size. So I need to stop slicing at down plus height and end at right plus width. I think this would be correct. And this is where we can maybe use the debugger. So let me just run this line as well, so we make sure that down and right are set. Because now if I run this line, I can check what shape image has, and image seems to have the right shape. So it's important when you do indexing like this, it's super easy to get with what's called a one off error, and that would basically mean that you stop the slice too late or too early. So like it's basically a pixel too narrow or a pixel too wide, and that's why I like to print out the shape and just check that I didn't do that. So now I think I did it correctly. So let's try to run all of this stuff. I just copy pasting it. Seems to look correctly. Okay. I think it's correct. So since I think it's correct, I'm not going to plot it. I'm just going to return the image, and then I'm going to remove the remainder of the function. I'm a little in doubt if I did this correctly. It's like, what's the coordinate of the top right corner? Is that image coordinate, or is it like regular XY coordinates? Interesting. But I guess the tests are going to give a good indication if that was correct. So it's like this annoying thing, and you probably encountered this in linear algebra, right? That the first coordinate in a plot, right? If we think about a graph, it's like along the x-axis, but in a matrix on image, the first coordinate is along the y-axis, right? That's the thing. Like, it's the coordinates of, if the starting coordinates is like as a plot where it's like the first coordinate is x-axis, so it would be like along this direction, or is it along this direction? That's the thing I wonder about. It's basically if you need to flip these two here. Who knows? I certainly don't. Maybe a bit of a more careful study of the exercise test would tell it, but it seems to be correct. So I'm happy. I guess I got it correct. it's also more logical to do it this way. So yeah, but that's yeah. It would certainly not be the first time I made this mistake. It's a very common to start mixing the two around. So when you work with images, it's a good idea that you just decide on a convention, whether it's like the first coordinate is horizontal or it's vertical, and just stick with that convention. And it should typically be dictated that with yeah, it should just be consistent with it all through your program, and you should be fine. Okay, so I think I'll end this here, and sorry a bit about the confusion with this stuff, but yeah, it is a confusing and annoying thing with images.